Oh, hi. Good to see you. I'm glad you stopped by. Hey, listen, I was just remembering that story you told me. Now, as I recall, the story was you were working as the controller for that home heating oil company, right? And a situation arose which kind of had people concerned. Apparently, there's a big snowstorm coming, and it was right before Christmas. You're gonna, deliver it. Then it's Christmas holiday. People are, the weekend and stuff. There's a holiday. But 6 families needed to get their oil, and what happens? One of the trucks breaks down, one of your company's trucks. So now this last remaining filler truck that's going to go out is the only one available, and they got to get around to all 7 houses, all 7 locations before the snowstorm hits. So the president, the operations manager, all these people are huddled in the office trying to figure out what route to take to be the fastest route so they can get home before the snowstorm. So somebody said, hey, you know what? The controller is really good at these mathematical type problems. Let's bring you into the problem. So you were explaining to me, they brought you in, they explained the situation. They have to get to, starting off at the place where the truck is, at the warehouse, and then getting out to the 6 locations and coming back. And you had told them, well, that's basically a classic TSP, or traveling salesman problem, which is very commonplace in the worlds of operations management. And so I said, I'm not really familiar with that. What can you explain what that is? What are you talking about? So yeah, it's right up here. You put it up here. So the traveling salesman problem, or TSP, asks, given a set list of cities and the distances between each pair of cities, what is the shortest possible route that visits each city exactly once and returns to the origin city? It is a combinatorial optimization problem important in theoretical computer science and operations research. And you explain that as you add the number of possible routes, as you add the number of cities, the number of possible routes increases exponentially. So just 4 cities has just 3 possible routes to evaluate. When you go to 5 cities, it increases to 12 routes. 6 cities has 60 routes, and 7 cities has 360 possible routes to consider. So you explained to me that, I said, well, what do you do now? Well, Microsoft Excel has an add-on program called Solver for optimization, minimum, maximum optimization problems. And this can be used. This is a perfect resource, Microsoft Excel. And I said, I had no idea. I had no idea I could do something like that. How do you do it? What do you do? What's the steps? What did you tell them to do? So you explained to me, here, put it up on the board right here. So you set up a grid. So in this example, you have 1 through 7. There's 6 places plus 6 residents, but you have the home base, so that's another node what you have to return to. So we're going to call them 1 through 7, just for ease of purposes. So you have the 1 through 7 across the top, across the bottom, and then you have, the miles, or it could be minutes, whatever you're going to be using here, is the distance between them. Okay? All right, okay. Okay, now what? Okay, well, the next thing you need to do is layer in a possible solution. Just any solution. You put that at the bottom. Like, for example, 1, 7, 2, 6, 3, 5, 4. And then at the end, the last one would, of course, reference back to the first one. Okay, all right, I see that. Now what do you do? Okay, well, underneath these, we're going to have to put in a reference to reference what is the distance in between each of those nodes. And we're going to use a computer function, Excel function called index. In Excel, it's equals index, open parentheses, you put in the array, and then you put in the row number, and you put in the column number. Okay, maybe, yes, sort of, I think, not sure. Is that it? Well, no, not now. You're explaining to me here. We'll show you what the next step is. You have to go into the data/solver. This screen pops up, and on that screen, you set the objective. So you give a cell reference for where the objective is. Now, in this case, what do you want to do? Maximize, minimize it, value? No, you want to minimize it. Click that radio button. You put in your changing variable cells. You set your constraints. You click the box for make unconstrained variables non-negative. And you click the box for solving method would be evolutionary. This is getting really complicated. Well, it's not quite done yet. Apparently, you got to go to the next step, which is go to options. Another screen comes up. And here, what you do is just simply populate the maximum time. So in this scenario, you suggested putting in 20, meaning 20 seconds. So I said to you, that looks too complicated. You think you could explain it using Excel? I mean, could you walk through it, the little walkthrough of what you do? And you said, sure, that might be a lot easier. Okay, so here it is. Why don't we take a look at that? Okay, hello to our integrated our Microsoft Excel solver to solve our traveling salesman problem for our problem regarding the fuel delivery. We have 7 nodes, which I'm calling 1 through 7 across the top, and then of course 1 through 7 across the bottom. And in this grid, we have the distance between each of the nodes. The intersection of the nodes is the distance. It could be in miles, it could be in time, in minutes. You can decide. What we do now is we put in a proposed route. So perhaps we'll start with 1, then perhaps we'll go to node 4, perhaps we'll go to node 7, then to 6, then to 3, then to 5, then to 2. I think that captures all of our nodes. 1, 2, 3, 4, 5, 6, 7, and then we come back to our starting point. Okay, so that's a proposed. I'm not saying it's going to be the exact one, but that's, now we put in equals, INDEX, open parentheses, and we capture our data in the array. Comma, we're going to pick up the first proposed node, and comma the second one to close our parentheses. At this point, we come into that cell, and we're going to take that array and we're going to change it from relative addressing to fixed addressing by adding the $sign. If you're familiar and comfortable with Excel, you'll know that we add $sign to change from relative addressing to fixed addressing. We're going to copy that formula over, and that will give us the distance between 1 and 4 is 37. The difference between 4 and 7 is right here, is 29. The distance between 7 and 6 is 19. So if any place here, we now have to put in a sum. This route is going to take 37, 29, 19, 18, 12, 22, and 34 miles. Oops. Equals sum. That's going to take a route of 171 miles. Well, let's see what Excel says is the optimal solution. We go to Data, we go over here to Solver, and this screen pops up. Now we want to set our objective. Our objective will be over here, right there. And where do we want the max, the minimum, or the value of? No, we want that cell formula, the total, to be the minimum. Okay, so we click on the radio button minimum. We want to change our variables, and that's these. This is our route, proposed route. So that's what we want Excel to key on. And we would add our constraints. The constraints cell reference will be the same thing we looked at above, the same values. And down here in this middle radio box, we drop down it's DIF, the difference. And it will automatically populate that the constraint is all different. We click on OK. Now we click on, we want the make unconstrained variables non-ledger to be checked. And down here where it says select a solving method, we want to change that to evolutionary. So we have our objective, we have our minimum, we have some variable cells, we have our constraints, we have a radio checked. We want this evolutionary, and we come to options. In the options cell, we're going to leave all these alone, but for the solving units and maximum time, we're going to put in 20 seconds, just 20. It says in seconds. Click OK. We're going to solve it. We're going to launch it. We're going to let
Excel do its thing and grind through all of the answers, all of the different variables that there are, and then come up with the minimum number. And that will be the solution to our problem. So we'll give Excel a few moments to grind through it. And we say stop. We say OK. And look at that. This is the route here. It's 159 miles or minutes. 2761534 and then 2. Or you can take the opposite route. So and you could start anywhere on this route. It could be 534 276, like I say, or go backwards, 6724315. And that's how we operate the program.
Well, that's really interesting. Yeah, I get it now. That doesn't look too tough. Okay, you got a few commands, you click the thing a few times. That really looks doable. I could do that. How'd it work out for you? Well, apparently you're telling me it worked out really well. The route you suggested got the driver home just as the snowflakes were starting to come into the area. Everybody was really pleased. And I said, that's amazing. You could use this type of algorithm through Excel to do all kinds of things, such as maybe the bus driver has to have a route to pick up and deliver their students, or the mailman needs a route to deliver their mail, or a census taker needs a route to how they're going to do their census. You know what? You're able to use mathematics for ways that are not just the debits and credits and the normal things that accountants use, but I see you really add value to an organization, and that's why you are one ace accountant. All right, let's give you a round of applause, all right?